Network analysis. Before we start network analysis, it is very important to understand some topic. Topic number 1, that is current division rule. So, when current will be divided, if one or more, if two or more than resistance are in parallel, then the current will be divided into different branches. For this network, if V is the supply voltage and I is the current, so R1 and R2 are in parallel resistance, so I will be divided into two branches, that is I1 and I2. Now I1 can be written as I into opposite arm resistance, that is R2 divided by R1 plus R2, and I2 equal to I into opposite arm resistance, that is R1 divided by R1 plus R2. Now voltage division law. When voltage will be divided, if two or more resistance are in series, then voltage will be divided. For this network, if V is the supply voltage, then R1 and R2 are in series, then supply voltage V will be divided into V1 and V2. So V1 can be written as V into same resistance, that is R1 divided by R1 plus R2, and V2 is equal to V into R2 divided by R1 plus R2. Now, voltage source. Voltage source is always associated with a series resistance. Just like this, V is the voltage and if R is the series resistance, and the combined unit is called the voltage source. So practically this R is the internal resistance of this voltage source. So current source. Current source always associated with a parallel resistance. So what is ideal current source? If the value of this parallel resistance becomes infinity, then the current will be maximized, so it is called the ideal current source. And what is ideal voltage source? If the value of the internal resistance is close to 0, then it is called ideal voltage source. Now dependent source. Dependent voltage source. Dependent voltage source are two types. Number 1, voltage dependent voltage source, and the number 2, current dependent voltage source. And voltage dependent voltage source, that is, if this is the voltage dependent voltage source, then its value should be in terms of some voltages, that is 2V0, where V0 is the voltage of some other branch. For this network, V0 is the value of the output voltage here. Now current dependent voltage source, the value of the voltage source will be in terms of some currents in the same network, that is for this case 3I0 is the value of this voltage source, and I0 is the current of some other branch, that is current through the 1 ohm resistor, that is I0.